The next thing that we're going to talk about is cameras. Now by default, Maya has a perspective camera. So right now we're looking in the perspective view, and if I just hold down my Alt button and my left mouse button, I'm able to tumble around in the view. Alt, middle mouse, and left button is going to allow me to dolly in and dolly out, and so on. If I want to display my cameras in the scene, if I just go up to the display menu, I'm just going to select the top view, display, show, cameras. This little green icon here represents the camera. It's going to go back to the perspective view. Now, if you are modeling something and you're tumbling around it and you're dollying in and so on, and you find that you want to maybe move back to a previous view, if you use the square brackets on your keyboard, that will move you back through previous views, and the square bracket beside it on the right-hand side is going to move you forward through the views. Okay, so we're going forward and backward. Now you'll notice that if I do an undo, that it doesn't undo any of my previous views. So if I want to include previous views in my undos, what I'm going to have to do is go into the camera attribute editor and scroll down to display options. There's something called journal command here, and if I just click that on, okay, and let's dolly in a bit here. If I wanted to go back to that previous view, all I have to do is now just go to the undo. Now there's a difference between dolly and zoom. It's going to go back to my 4 views and just move in a little bit close to this top view. The difference between a dolly and a zoom, with a dolly you're actually physically taking the camera and moving it closer to an object. So if I just hit the Alt, left and middle mouse button, see how that camera is moving in? Okay, so it's actually moving the camera, whereas a zoom, I'm changing the lens. So view, camera attribute editor, and it's the focal length here. So that's going to be your zoom. And if we just look at the icon, I'll give you a hint. Okay, see how that lens is changing? That's because that's a zoom. Just going to close this up and open up the render globals. Now the render globals is where you're going to set up, how many, what the image format is of an object, which cameras you're going to be rendering from. You control all your anti-aliasing and so on from the render globals. Let's just go under resolution. Okay. Now this is going to be the size that you're going to render out at. So you'll notice that by default the preset is at 320 by 240, which is a good size to be rendering out test renders at. But most likely you're probably going to be rendering out at CCIR 601 or Quantel NTSC. Okay? So that's our television standard NTSC. Now, in order to be able to see exactly what is going to be rendered out at this resolution within your perspective view, what you're going to need to do is, again, go into the attribute editor. Okay, and also just under the display options here, just turn on display film resolution. Now you'll notice that there's kind of a white line along the side here, and you can see 720 by 46. That's what I set my output resolution to be. We're not exactly seeing everything that's contained within that box. So I'm just going to back up the camera a little bit by changing the overscan attribute to something like 1.3. Let's close that up. So now you can see anything that's contained within this box or the resolution gate will actually be rendered. Anything outside this box won't be rendered. I just want to make a note that when you do change your overscan, you aren't actually changing anything about your camera. It's just for display purposes only. You're not actually dollying out or anything. Now the next section that we're going to talk about is rotoscoping. Now what rotoscoping is is just the process of positioning and animating objects relative to a background, maybe a live action sequence that you've digitized in, or even a still. So let's look at maybe some of the problems that can happen when we start rotoscoping against NTSC digital video. Sometimes this is also known as D1 video. Now the challenge that's faced with this is that usually the digital video that we are bringing in is generated by devices that usually use non-square pixels. So if we just look at a diagram here, okay, so in terms of D1 video, the pixels that are generated are actually taller than they are longer, okay? Now what happens is when we digitize this in, our computer monitor is displaying square pixels, okay? So what's happening is our digital video is actually being squished a little bit, okay? So it's taking this non-square pixel and we're viewing it through a square pixel. Just on a side note, the pixel aspect ratio is just basically x divided by y, and you get some kind of aspect ratio. So for the D1, it's 1.1, excuse me, 1 divided by 1.1, and you get 0.9. Okay, so I'm just going to show you another image to illustrate just how something can look squished on a computer monitor. So this is a sphere that I rendered out at 720 by 46 digital video, NTSC, and you can see it's actually a little bit egg-shaped. Okay, so it's not perfectly round. So you can imagine the problems that you're going to have because we're not actually getting a good, accurate display of this video on the computer, so that positioning or animating some kind of computer-generated element against it correctly is next to impossible. So let's just go ahead and go back to our scene. I just want to point out something real quick. Back to the render globals, just 720 by 46, and there's our pixel aspect ratio that we just talked about. Okay. So I just want to also point out that there's something called a device aspect ratio. The math for figuring out the device aspect ratio is in your book. But let's go ahead and set up for rotoscoping. So we're rendering out at NTSC, and we're going to bring in video. So what I'm going to do is I'm going to just go into the attribute editor for the camera and just point out the film back. Now, unless you are rotoscoping or bringing in digital video, you really don't have to be concerned with this section. Just to sort of quickly go over what the film back is, I'm just going to stow this. And let's just look at our diagram here. Okay, so this is our camera. This is where the film back information is found on the camera. So basically we have a film gate here, and you can see that there's a square cut out of the film gate. Now this square is usually referred to as the aperture. So our film here, just this region here is going to be exposed in that film. And then in order to hold this film gate and the film in place, we have something called a film back. So it's just a metal plate that holds everything into place. So let's go back to Maya. Okay, and let's just go back to that attribute editor. Okay, so you notice here we have also a bunch of presets too. And there's our camera aperture, and then we've got something called film aspect ratio. So what I'm going to do is, we've displayed the resolution gate, now I'm going to display the film gate. Okay, now you'll notice that the film gate is not actually matching what the resolution gate is. So what I'm trying to say here is what's coming in is not going to match up with what's going out. So we want to make sure that these two gates match up. So we can do that by making sure that the device aspect ratio that we looked at in the render globals was a value of 1.33, making sure that that aspect ratio matches with the film aspect ratio. Now we happen to have a preset under the film gate called 35mm TV projection, okay? And you notice that the film aspect ratio has changed and both the gates now match, okay? So they're both the same now. So now we're ready to bring in our digital video. So let's go ahead and, whoops, I want to bring that back. Let's go ahead and create an image plane. So just create, okay. And let's go and find an image. I'm going to grab that sphere that we used earlier, the D1 sphere, okay. And you'll notice that still looking a little squished here, okay. So what we're actually going to do is we're going to stretch this image to match the gates, okay. So we are actually changing the shape of the image or stretching that image so that we get an accurate view of that image, and then we can go ahead and correctly animate or position our element. So we're just going to go into the attribute editor for the camera, and just under the image plane tab itself, there's something called placement, and so what I'm going to do is fit to size. Okay, so we stretched out that sphere, that image of the sphere, and now we're getting a perfect representation of what that sphere actually looks like when it's on video. And just to show you, okay, you can see that it's now perfectly round. With regards to cameras and Mental Ray for Maya, everything is almost exactly alike. Image planes are almost exact as they are in Maya, except maybe with a slight shift, so be aware of that. If we go to the camera attribute editor itself, go to View, select Camera, you'll notice that there is a Mental Ray section. And if we just open that up, you'll notice that there's a number of ports for connecting Mental Ray for Maya shaders into these ports. So for instance, if I needed a lens shader, I would go to the Mental Ray lenses, select the oversampling lens for instance, and then I would just basically middle mouse drag it and drop it in there. Okay, so just quickly going over these, the output shader allows for post-processing effects, so glows and contours, things like that. The volume shader is going to allow for volumes, so things like smoke, cloud, fur. The lens shader allows modification of the ray direction and origin, so a lens type effect. And environment shader is going to attach some kind of an environment into this port, and so that you can render with an actual environment in Mental Ray for Maya.